reteaching on inverses and double inverses, kind of like rainbows and double rainbows.
Ask Mommy. Ask Mommy quick.
So first, and drop, sit down easily, my coordinate grid. It's already telling you that's in between pi over 2 and 3 pi over 2, so it can't be over here. I'm looking at the other two. And it's negative. Remember, goes all sad turtles. So this is where sine would be negative. So sine is my opposite over my hypotenuse. So I have to look at what is this angle right here. So if I take that angle, that would be 180 plus this angle in this location, since it's straight across from my square root of 3, this would be 60 degrees. So I have 180 plus 60 degrees would give me 240 degrees. And then I'm going to change it to radians. Your answer should always be in radians. So 240 times pi over 180, your answer is 4 pi over 3. Second one, again, start with my coordinate grid. It's already telling me it's in between pi over 2 and 3 pi over 2, so it's not going to be over here for sure. And it's all sad, so I know for sure my triangle goes over here because tangent is negative. So it's my opposite, toa, over my adjacent. This would be my negative. So this would be my square root 2, because if I see a 1 and a 1, then my hypotenuse would be a square root 2. So now this angle right here is 45. So this angle is what I'm looking for. That angle in degrees is 135. So I have to change that into radian measure, like so. You get 3 pi over 4. Next one's a little bit trickier because it's a secant. So I'm going to actually change this to 1 over cosine is equal x is equal to 2. So now I'm going to flip both sides. So now I know cosine is going to be equal, cosine x is equal to 1/2. The reason why is because this is 2 over 1. So again, you're taking the reciprocal of both of them. So if I look at this one's a lot more confusing because I'm in between pi, or 5 pi and 6 pi. So I'm actually going to draw two separate coordinate grids. Now first I'm going to try to figure out what coordinate grid between 5 and 6 pi is. So if I start here, I'm going to see how many circles I do. So this would be pi, this is 2 pi, this would be 3 pi, 4 pi, 5 pi. So now I know that in my coordinate grid it has to be one of these two below. And since it's going to be cosine is positive, so all sad turtles cry, this is where cosine is positive, this is where I'm going to draw my triangle. So my opposite, or my adjacent is 1, my hypotenuse is 2. That means this third side has to be square root 3. So actually it would be negative square root 3. So now my angle here is going to give me 30. Just kidding. 60, because across from your square root 3 is 60. So this angle, I have to figure out what that is first. That angle would be 300. But if I look back, I had to do a couple of circles before I could actually get to that 60. So I have 300, because that's the original angle. And I have to look at how many times did I have a circle. So I have 1, 2 circles. So plus 2 circles would be 360 plus 360, which would give me 1,020, and then I'm going to change that into radians. So it's 17 pi over 3. Sorry if you don't really have never had me before, and I talk weird. So inverses. First I'm going to write down my coordinate grid. So inverses, we have a limitation on inverses. If it's sine, that means it has to be in the first or fourth quadrant. So I know already that I can get rid of these two. Sine is positive, so my triangle will be in the all. So sine is my opposite over my adjacent. So this angle here would be across from my square root 3 is going to be 60. So then I just have my 60 which is the same thing as pi over 3. Cosine. Cosine is either in the first or second quadrant, so I now can cross those out. Cosine is always going to be with your x. X is 0. So this is the spot where x is 0 and y is actually 1. So this spot, that angle right there, this one, is pi over 2. And the last one. One thing I notice is that you do have to rationalize the denominator. So actually, if I work this backwards, we don't have any ratio in special triangles that have 3 and square root 3, but we do have 1 over square root 3. More precisely here, negative 1 over square root 3. So again, tangent's going to be in your first or fourth, so I know it's for sure it's not going to be one of those two. And it's all, and this one's negative, sad turtles cry, so it's going to be in this quadrant. My opposite is negative 1, my adjacent is square root 3. My angle here is going to give me 30 degrees. So since this is, you always, for the inverse, you always want the shortest distance. The shortest distance would be backwards, like this. Clockwise, it would be a negative pi over 6. So next one, I'm going to have to draw 2 different pictures here because I'm doing 2 different things. So draw my coordinate grid. I'm going to work on the cosine of pi over 3 first. So pi over 3 would be in this quadrant right here. Pi over 3 is the same thing. My reference angle would be 60. So across from 60 is your square root 3. Your adjacent would be 1 and 2. So cosine now is my adjacent over my hypotenuse. So now what I'm dealing with is sine negative 1 of positive 1/2. So now you evaluate that. It's a positive 1/2. So it's in the, when I'm doing the inverses, for sure not going to be over here. So it would be in my first quadrant, opposite over hypotenuse. And my opposite is 1, so that means this is 30 degrees. And if I change that to radians, it would be pi over 6. Next one. So I'm first taking the inverse of 1/2. Again, it's either in the first or fourth. Since it's positive, it's going to be in the first quadrant. So my opposite is 1, my hypotenuse is 2, because it's so this would be square root 3. And then this angle would be 30. So now I'm doing tangent of 30. For this case, I don't really have to change it to radians. And actually, I could just use the same triangle, because if it's 30 degrees, it's going to be in this spot right here. So it's still going to have the same ratio. 1, 2, square root 3. And now I'm looking for tangent. Tangent is OA, so opposite over adjacent. And you have to rationalize that. It should be square root 3 over 3. And last but not least, for this section at least, there's a lot on this reteaching. Tan of 7 pi over 4. So that's going to be in my fourth quadrant right here, because this is 7 pi over 4. My reference angle is 45 degrees. So in a 45 degrees, it's 1, 1, and square root 2. This actually is going to be negative 1 because I went down 1. So again, tangent is my adjacent, my opposite over my adjacent. So this is the same thing as negative 1. So now what I'm going to be evaluating is the inverse of negative 1. Cosine is the same thing as your x value. So where is x negative 1? X is negative 1 over here, so it would be negative 1, 0. So this angle right here would just be pi. These y'all got to do in your calculator. If you don't know how to use your calculator, you're going to have to ask the question. The first thing I'll do is just rewrite the equation, what it should look like. Remember, this portion you should plug into your window. This is your x min, x max, x min, x max, x min, x max. What you plug into your y equals would be sine of x subtract 0.761. That's what you type into the first one, and if you plugged in to calculate your zero of your function, your answer would be 8.56. Second one, you don't want to have secant. That's the same thing as 1 over cosine. You can put this exactly into your calculator and then add, you're adding 1.932. Put your max min of minimum is pi, x maximum is 2 pi, and if you evaluate it, it would be 4.17. Left bound, right bound, guess. That's what you're doing here. Last one, 1 over tangent minus 2.47. X min is 0, x max is pi. Second trace to get to calculate, you want the zero of your function. Left bound, right bound. 0.385. I realize that this is pretty long, but there's a lot of questions on this reteaching. Hopefully this helped you. Have a great day.